Hello everyone. We'd like to continue our lecture online. We've so far discussed about linear data structures. We said these linear data structures are a type of data structure where data elements are arranged in sequential order. Data elements are arranged in sequential order. It means you have these data elements, you can access them by accessing from individual element. You move from one element, you go to the other in that order. These data structure are arrays, linked list, stack, and queue. Arrays, linked list, stack, and queue. We've already looked at arrays and linked lists. Today, we want to look at stack. Stack is different from the array and the linked list that we've looked at. With your array, you can easily access any of the elements at any point. That is, you can insert at any point and you can remove from any point. The same applies to linked list. You can insert and you can remove from any point. Stack is a data structure where you can remove and you can insert only from one point. So today, after the lecture, you are supposed to have understanding of the concept of stack. So you look at the concept of stack. We also look at the operations of stack, some of the operations that are performed on stack. Then you look at stack implementation. You look at stack implementation. So now let's start with the concept of stack. As I said earlier on, stack is a data structure that is linear in nature. It means data elements are accessed sequentially. But these data elements, we are saying that you can insert them in that structure or you can remove them from that structure only from one point. And that point is what we refer to as the top. So stack is a data structure in which insertion and deletion are done at the point called top. In this case, it means when you put element in the stack, the last one that you put it in the stack will be the first to be accessed. We therefore refer to this situation or mechanism as last in, first out. Last in, first out. So the last that was put in the item that was put last in the structure will be the first that you can remove from the structure. There's no way you can remove the old or the first one from the structure without removing the current one. Whenever you want to put something into the stack and the stack is full, we refer to that state as overflow. So overflow state is where the stack is full and you want to put in something again. Now, the other point is when the stack is empty, we refer to that state as what? Underflow. Underflow. It means the stack is empty. So anytime you want to remove something from the stack and the stack is empty, we refer to that condition, that state as underflow. So let's look at this diagram. We have a stack that consists of 5 elements. That is 10, 20, 30, 40, and 50. 10 was the first one that was put in the list. Later, you put 20, 30, 40, 50 in that order. So the 50 is the one that is at the top now. So you could see that our top pointer is pointing to 50. The top pointer is pointing to 50. That is the current one. So if you want to access data, then the one that you can access is the 50 because that's the one at the top. Until the 50 is removed, you cannot access the 40. Until the 40 is removed, you cannot access the 30 in that order. These are the operations of stack. There are two major operations that we perform on stack. We have the push operation. That is when you want to put something into the stack or you want to insert an item into the stack. We refer to that operation as push operation. And whenever you want to remove an item from the stack, there's another operation. We don't call it pull. Don't think that because this one is push, then the other one is going to be pull. We refer to that one as what? Pop operation. So the pop operation is used to remove or delete an item from the stack. So when you are putting in, you say you are pushing. When you are removing, you say you are popping. So if you want to remember the pop, you can pop champagne. Look at how the sound goes. Pop, it means something needs to come out from the bottle. Now the next one is what we call peak. The peak operation. You see, I mentioned the two major. Remember, I said the two main, which is the push and the pop. The push is just want to remove, you want to put something in. The pop is when you want to remove or delete. But you have a third one, which you call the peak. Here, you are just wanted to look at what is at the top of the stack without necessarily removing it or pushing. So when you say you are picking, it means you just want to access the data item there. You are not just deleting that data item. You just want to access that data item over there. You just want to find out, for example, you just want to find out whether that record is in the list, not that you want to remove and not that you want to add. So these are the three major operations of stack, but we are going to look at only the first two, the push and the pop. So if you look at this diagram, you could see that we have a stack having data element 1, 2, 3, 4, 5, and the one at the top is 5. Anytime you pop, what happens is that our pointer pointing to 5 must be reduced and point to 4. Anytime you pop, the pointer must reduce and point to 4. So you can see that when 5 is popped, the pointer now points to 4. If you are going to pop 4, the pointer will now move toward 3 in that order. So this one works like your WC. I've been using this scenario a long time, or most of the time. When you put water in the reservoir of your WC, you can see that the ball there will rise up. So as you are putting the water, the ball will be rising. But as the water is going, when you flash and the water is going down, you could see that the pointer or the ball will be going down. So the same applies here. Whenever you are adding something to the stack, your top pointer will raise. As you are putting water in the reservoir, you see that the ball will start raising. When you are taking water from the reservoir, as you are flashing, you could see that as the water goes down, the pointer or the ball will now also be going down. The same applies to the pop and the push operation. Anytime you insert an item into your stack, your top pointer must be increased by 1. So top is always top plus 1. But whenever you remove an item from your stack, the top pointer must be reduced by 1. That is top is equal to top minus 1. So these are the two major operations that we say we are going to look at, the push and the pop. Stack is an abstract data type or data structure because its implementation is left to the programmer. The programmer can decide how to implement the stack. So we normally refer to that as an abstract data type or data structure. We can implement stack using array and we can implement stack using linked list. So these are the two data structures that we can use to implement our stack. We can implement the stack using an array or you can implement the stack using linked list. We are going to look at these two implementation, how we can do the implementation in an array and how we can do the implementation in linked list. So let's start with the array implementation of stack. Array implementation of stack. Whenever you want to implement a data structure using other data structure, then it means you want to take advantage of that other data structure. So here in this case, you want to implement stack using array to do the implementation. What you are supposed to do is that you want to take advantage of array. There are some properties that array is having that the data structure stack is not having, and you must take that properties. But whenever there's a conflict with the two data structures, for example, stack is having a certain property that is in conflict with the one that you want to implement, which is the array, then you must take the base structure, which is the stack. I hope you understand that. Whenever there's a conflict, since you want to take advantage of array, if there's any array property that is in conflict with that of the stack, then you must take that of the stack and ignore that array. For example, with an array, you can insert at any point. But remember, stack is saying that you can insert only at the top. In that case, we cannot take that property of array. We must just concentrate on the property of the stack. So we are going to look at how to implement our stack using array. So let's take the diagram there. We have an array of element A, B, and C. And this array has a size of 7. Please, in stack, we start numbering from 1. So if in array you are going to start from 0, there's a conflict. So you must take that of the stack and not array, because we are implementing the stack using array, or want to use array to implement our stack. So you could see that we have the top pointing to 3, location 3, which contains the element C. Then we have a variable called maximum stack. That is telling the maximum size of the array, which is what? 7. So if you want to implement your stack using the array, that's the array implementation of stack, then you should have these elements. You should have an array of elements. You should have your top variable pointer. Then you should have a variable that will hold the maximum size of your array. So we are saying that whenever you want to implement your stack using array, then it means the advantage that you are taking from array is that the size of the array has to be declared in advance. The size of the array has to be declared in advance. And that's what we are doing here. You have to put that one into the variable which we call the maximum stack. So these are the 3 major elements that you need. There should be an array stack that will contain the element that you are looking at. There should be a top variable, that pointer that will point to the element at the top always, and there should be a variable that will hold the maximum size of your array. So we want to look at the algorithm where you can implement your array using the push algorithm, using the pop algorithm. So let's start with the push. Push here means you want to put something into the stack. You want to put something into the stack. Now with the algorithm, the push algorithm should have these parameters. The push algorithm should have these parameters. It should have the stack. As I said earlier, there should be an array called stack. There should be a variable called top that will contain the location of the top element. There should be a variable called maximum stack that will contain the size of the array or the stack. And there should be an item, what you want to put into the stack. But before you can insert, remember we said when the stack is full, you will be in a condition or a state called overflow. Anytime you want to insert into a stack, you must check whether the stack is full. So in our algorithm, step 1, we need to check whether the stack is full. Our stack will be full only when the top variable, the value that it contains, is the same as the maximum stack variable. Because if you go back, you could see that as we move to insert an item to the stack, we have A, B, and C. Now, if you decide to insert D, you could see that the D will go to the location 4. The D will go to the location 4. If you decide to insert E, it go to location 5. If you decide to insert F, it go to location 6, and G will go to 7. So when G get to 7, you could see that the top pointer will not be pointing to 3 again, to be pointing to 7. So in this case, the top pointer contains 7, and the maximum stack also contains 7. In that case, we are saying that the stack is full. So if the stack is full, then it means you cannot insert anything into the stack, and therefore you need to exit. So our algorithm here is saying that we should check if top is the same as maximum stack. If it is, then we print overflow and exit. But if our stack is not full, then what you have to do is that first we need to adjust the pointer to point to the next empty location. Because if you don't do that and you just insert at the top location, the new item will overwrite the old item. So in that case, you are not going to get the old one anymore. So the best thing to do is to adjust the top pointer to point to the next empty space. So set top equals top plus 1 will just point to the empty space. Then the third step is saying that you now put the item into the location where the top is pointing to. So set stack at top equals item, because now the top is having the empty location address. So you put it there, and the last one say that you exit. So basically, that is how the algorithm goes with the push algorithm. That's how it goes. Now let's look at the pop. Pop means we are removing something from the stack. Here too, the algorithm should have this element, the array stack, your top pointer, and the item. Here we don't need the maximum stack. We don't care whether the stack is full or not. We don't need to look at that stack, maximum stack variable. We don't need it because we want to remove. Is that okay? You want to remove, so you don't need to consider that maximum. You don't need the size. You are not going to use the size to do anything over here. But here, if you want to remove, remember we said there are two conditions. Either it's an underflow or overflow. Here you want to remove. So the first thing that you have to check is whether the stack is not empty. Whether the stack is not empty. So we are saying that one, if top is the same as 0, remember we are starting from 1. So once the last element is removed, the top pointer is going to be top minus 1, and that will reduce to 0. So if the top is equal to 0, then it means there's an underflow. There's an underflow. It means the stack is empty, and therefore we need to exit. But if the stack is not empty, then you must remove the top item. Here, the opposite happens to that of the push. Remember, with the push, we adjusted the pointer before you place in the item. Here, you must put the item, the top item into a variable item before you adjust the top pointer. Because if you do adjust the top pointer before, you'll find out that that item there will not be traced again. Remember our memory leak and dangling pointers that we discussed. So here we said set item, that's to set item equals stack at top. Then when that one is done, then the 3 is saying that you need to adjust the pointer, you need to reduce the pointer. So set top equals top minus 1, then we exit. So these are the two basic algorithms for the array implementation of stack. The array implementation of stack. Now let's look at the linked list implementation of stack. If you want to implement the stack using linked list, as we said earlier on, then you want to take some advantages of the linked list. There are some advantages of the linked list that you want to take. Here, one of the advantages is that the size is supposed to be dynamic, unlike the array where the size needs to be fixed. The size is supposed to be dynamic. You can increase it at any time, you can reduce it at any time. Now, linked list also has this advantage. Insertion and deletion is done anywhere, and therefore the cost is therefore less than that of the array. But remember, we are not going to take this property because it conflicts with. Okay, let's look at this. It said insertion and deletion is done anywhere. It conflicts with that of the stack. With the stack, insertion and deletion is not done anywhere. It is done only at the top. And therefore, this property will not be taken. The property that you are going to take about the linked list is its dynamic nature. Its dynamic nature. But we still look at all the other features of linked list. For a linked list, you should have your data field as usual. The item, that is where the item to be stored will be located. There should be the link field that will contain the address of the next element in the stack. Since we are implementing our stack, we need a top pointer that will always point to the first node which contains the last entered element. Then we need a null pointer. We will need a null pointer which should always point to the last node, indicating the last or the end of the stack, indicating the end of the stack. Here we're also going to look at the two major operations, the push and the pop. So let's start with the push operation using the linked list implementation. With the push, you need your data variable, that is the variable that holds the data. You need the link pointer that will point to the link. You need the top. Here you are going to put something into the linked list. Remember, in linked list, before you can insert, you must check whether there's an empty node available, and that one must be in the available list. So you need a pointer that will point to the available list. So you need the avail pointer here. Then you need the item that you want to insert. So these are the parameters that is needed for our algorithm. First, let's check whether there's overflow before we insert. For linked list, to check the overflow, you must check whether the avail pointer is pointing to an empty node. If the avail pointer is not pointing to any empty node, it means it is null. And if it is null, then there's no empty space to insert, and therefore there's an overflow, so you exit. But if there's an empty space to insert, then what you are supposed to do is that you need to get that empty node, put in your item, then you now connect that node into the actual list. So you go to the available list, you pick a node, you put in your data, then you connect that node to the actual list. So the step 2 is doing that for us, is taking a new node from the empty list. And we are saying that you should first assign, you're just going to do swapping. We want to swap between the avail and the link of avail. And to do that, we need a third variable called new. We will need a third variable called new. So we assign the avail content to new, then we assign where the avail was pointing to, that's the link of avail to avail. If you do that, it's going to just ensure that our new node is going to be removed from the avail. So it means the avail is now going to point to the next empty node, not the first node. What you are going to do in the third one is you are now going to put your item into the data part of the new node. So we could say that set data of new equals item. Then 4, what you do is that you assign the top. You assign the top variable to the link of new. So where the top was pointing to, you allow the new node to point to where the top was pointing to. Then fifth point is that you assign the location of the new node to top, so that, remember, this is a stack implementation. So the current element should always be at the top. The current element should always be the one that the top pointer is pointing to. So the location of the top of the new node, which is the new, should be assigned to top. Then you exit. So that is the algorithm for the push. Similar is applied to the pop. With the pop, you still need your data, you need your length, your top, your avail, and the item. But the opposite happens. With the push, you must check overflow, but with the pop, you must check underflow. You must find out whether the actual list is not empty. To do that, we check the top pointer. If the top pointer is not pointing anywhere, then it means there's no list to take something from. And therefore, we write underflow and exit. So if top is the same as null, then we write underflow and exit. But if it is not null and is pointing to a node, then what you do is that you go to the location, the data portion of that node where top was pointing to. So data at top is now assigned to an item, so that your item will contain that value that you want to remove. Then what you do is that you adjust the top pointer to point to the next item in the list. Remember, that's linked list. So the top pointer must point to the next node in the list. And here too is a swapping thing that you need to do. So you need a temporary variable. So here we are using temp, not just to confuse ourselves with the new. You just want to use a different variable called temp. So we are saying that you assign the top to temp, then you assign the link part of where top was pointing to top, so that that will remove the node from there. Remember, anytime you remove garbage collection, remember the empty node must be taken to the available list. So that node that has been taken from the actual list, the fourth point is now going to insert that one into the available list. So we are saying that set length of temp equals avail and avail equals temp. These two statements will now adjust by assigning the empty node into the available list. Then you exit. So basically, this is what we want to look at today. We wanted to look at the concept of stack, we wanted to look at the operations of stack, and wanted to look at how we can implement stack. We have seen that stack is just a data structure which is linear in nature, where data elements are accessed at only one point, that is the top. We can remove and insert data only from the top. We also look at the two major, though there are three, the two major operations of stack. That is the push operation and the pop operation. And we said we can implement the stack because it's the abstract data type, and therefore we can implement it in any way that we want. And the two major ways that we can implement our stack is to use linked list to do the implementation, and or to use an array to do the implementation. Our next lecture will look at the application of stack. How can we apply the stack in our everyday life? There are a lot of areas where we can apply this stack. We look at application of stack. So just read around this application of stack, so that in our next lecture, when we start, we are going to get better understanding.